Friends, in today's video, we are going to talk about what is vector differentiation. We already know physical quantities are two types. One is a scalar quantities and second one is a vector quantity. Now, differentiation of scalar quantity is called scalar differentiation. And differentiation of vector is called vector differentiation. Now consider some physical quantity R. R, we can think about the two ways. One is the R in the scalar form, R in the vector form. Suppose R is depends upon T, some parameter T. Suppose say T is the time. So R is the function of T. So we can write R is the function of T. And in second case, the vector R is a function of T. On one side, it is a scalar quantity, R equals to f of t. This is a scalar form. And vector R equals to f of t. It is a vector form. We can find out derivative of R in case 1, that is dr by dt, differentiation of R with respect to t. In second case, it is a vector R. In second case, even we can find out derivative of vector R with respect to t. In case 1, it is called as a scalar differentiation. In second case, it is called vector differentiation. Suppose we consider function R equals to f of t and consider delta t be the small increment in t. So delta t is a small, very small increment in value of t. In that case, how to define scalar derivative, scalar differentiation? Scalar differentiation is defined as dr by dt equals to limit delta t tending to 0 f of t plus delta t minus f of t divided by delta t. In this definition, vector is not involved. It is a purely scalar form. Therefore, it can be called as a scalar differentiation. And in case of vector differentiation, everything is remain the same, but R is taken in form of vectors. R is taken in terms of vector. So it is a differentiation of vector R with respect to t. That is a dr, vector dr upon dt equals to limit delta t tending to 0, and here is it is in the form of vector. So here the vector will come here, and now function will be in the form of vector. So vector f t plus delta t minus vector f of t divided by delta t. What is delta t? Delta t is very small value. It's called as an infinitesimal value. It is almost approaching 0. Therefore, we take delta t equals to 0. So this is the definition of vector differentiation. Now consider a point P on the curve. We have the vector OP. The vector OP is given by vector R. The point P is moving along the curve. You can also notice that as the point P is moving on the curve, the magnitude of vector R is also changing. That is, this is the first position, this is the second position, it is the third position, and it is the last position. So the particle is moving on this curve from point P to Q. And in first case, the magnitude is R1. In second case, the magnitude is R2. In third case, the magnitude is R3. In fourth case, the magnitude is R4. So every time the magnitude is changing. So the dr, vector dr is changing as the particle is moving from point P to point Q. As the particle is moving along the curve, it's every time its direction is also changing. So at position 1, the particle is directed at point 2, and the position 3rd and position 4, every time the direction of the particle is changing. So on one side, the magnitude of vector r is changing, and the second side, the direction of the particle is changing. So we can say the direction, that is the dr, is a vector quantity. So we want to find dr by dt because the magnitude of dr is changing as the time is lapsing, as the direction of the particle is changing. So dr by dt is nothing but vector differentiation. It is a differentiation of a vector quantity. So that is a vector differentiation. For smaller duration of time, if delta t equals to 0, then the point P approaches point Q, implies PQ becomes a straight line, is almost a straight line. Therefore, dr by dt we can assume as a velocity vector. Why it is a velocity vector? Because for the very smaller duration of time, delta t tending to 0, P approaches Q and PQ becomes a straight line, and when the particle is moving along the straight line in particular interval of time, that becomes the velocity. So there is a displacement upon time, so that is equals to velocity vector. So dr by dt gives velocity vector of the particle as the particle is moving from point P to point Q along the curve. Suppose delta S equals to length of arc PQ and P is approaching Q, that is P and Q are very close to each other. And let us call the coordinates of point P as a x, y, z. Now, if you want to find out delta S, that is a length PQ. From here to here, the length is PQ. So, the delta S square, by using distance formula, we can easily tell delta S square is equal to delta x square, delta y square plus delta z square. Call it equation number 1. Now dividing both sides by delta S square. So we get 1 equals to delta x square upon delta S square plus delta y square upon delta S square plus delta z square upon delta S square. Now as point P approaches point Q, delta S is almost tending to 0. In that case, delta x upon delta S is equals to dx by ds, and delta y upon delta S equals to dy upon ds, and delta z upon delta S is equals to dz upon ds. Therefore dx upon ds whole square plus dy upon ds whole square plus dz upon ds whole square equals to 1. Suppose the coordinates of point P are x, y, z and vector OP equals to vector r. Now in terms of position vector r, we can write vector r equals to x into I cap plus y into j cap plus z into k cap, and we can write dr, vector dr equals to I cap into dx, j cap into dy and plus k cap into dz. Now dividing both sides by ds, so we get vector dr by ds equals to I cap into dx by ds plus j cap into dy by ds plus k cap into dz by ds. Now finding magnitude both sides. So magnitude of dr by ds is nothing but dr by ds whole square under root of, and magnitude of RHS term is under root of dx by ds whole square plus dy by ds whole square dz by ds whole square implies dr by ds equals to under root of dx by ds whole square plus dy by ds whole square plus dz by ds whole square, where vector dr by ds, this is nothing but tangent vector. Friends, that's all in this video. I shall be continuing this topic and talking much more about vector differentiation in my next episode. So please keep on watching. Meet you again with the next topic. If you like the video, please like, share and subscribe the channel. Meet you again with next topic. Till then, wish you good luck. All the best.